Hello and welcome to this episode of Night Sky News for April 2026 with me, astrophysicist Dr. Becky Smethurst. This is the show where we chat about what you should look out for in the night sky in the next few weeks, and then we chat about what's been happening in space news in the past few weeks. In this episode, we're chatting about the fantastic Artemis II mission and whether it was worth the cost. Then we'll chat about JWST's latest look at the planet Saturn, which looks incredible, and then this incredibly weird super puff exoplanet that we cannot explain. There's chapter markers down here if you want to skip ahead to any specific news story, plus any scientific research papers I mention are all going to be linked in the description down below, free to read. So, without any further ado, let's kick things off and start by looking up. I am in Joshua Tree, California this month, a protected dark sky site with very little light pollution, so I've been enjoying some wonderfully dark skies, especially because we're getting into Milky Way season as we get closer to summer. The Milky Way is our galaxy of billions of stars, our island in the universe. It's a flat disk shape, so we see that as a glowing strip across the sky, which is the combined light of billions of stars too far away for us to see individually. A long exposure with a camera or your phone will reveal the detail of all the gas and the dust between the stars, but with just your eyes it will look kind of like a diffuse kind of glow, like someone has spilt milk across the sky, which is how it got its name, the Milky Way. Now if you're in a city, you will not be able to see this. The light pollution is too bright. It drowns out that just faint glow of the Milky Way. The same is true if the moon is too bright as well, so the best time to look is around the new moon, which this month is on the 16th of April. Now the further south you are, the better view you will have, and the Milky Way will be visible all night. But for those of us further north, we'll only have the best view in the early morning just before sunrise at this time of year. If you don't want to get up early, and I don't blame you, don't worry, because as we get later into spring and summer, the Milky Way will start to become visible before midnight. By next week, the moon will be a half moon, and it will have joined Jupiter in the west after sunset near the stars of Castor and Pollux in the constellation of Gemini on the 22nd of April. Jupiter is one of the brightest things in the night sky after the moon and Venus, so hopefully you should be able to pick it out from the background stars, especially since you'll have the moon sort of signposting where to look. Speaking of Venus, it's also visible for about an hour or so after sunset at the minute. It's lower towards the horizon in the west, and as we get into May, Venus will rise higher and higher in the sky, meaning it will be visible for longer after sunset. Also notice how Jupiter and Venus will be getting closer and closer together over the next couple of weeks as they move along their orbits. So much that eventually by the start of June, they're going to come within just 1 degree of each other, about the width of 2 full moons apart. This is what's known as a conjunction, and it's a really beautiful sight to see when they're that close together, but it's almost more fun if you've actually seen them getting closer and closer together. So that is your homework for this month, is to keep an eye on Jupiter and Venus. In the meantime, the Lyrids meteor shower will also peak soon on the night of the 22nd and into the morning of the 23rd of April. It's a fairly average meteor shower, so it's around about 10 to 20 meteors per hour. So that's shooting stars, so tiny little lumps of rock that are burning up in the Earth's atmosphere. What it means is that there should be one shooting star every 3 to 4 minutes or so. And with so few meteors in the shower, it can be a little bit hit and miss, especially if you're not in a dark sky. Thankfully, the moon this year will be a half moon on the night of the 22nd and will set around midnight, so at least there's no bright moon to wash out the faint meteors. If you are going to try and spot some of this, the best time to be out is around about midnight if you're in the northern hemisphere and you want to look towards the west, or if you're in the southern hemisphere, it's going to be in the wee hours of the morning and you're going to want to look directly up. The better meteor shower to look out for this month though is the Eta Aquarids meteor shower, which this year peaks on the night of the 5th of May and into the morning of the 6th of May. The further south you are, the better the show will be for this one though, as the radiant, so the place where all the meteors appear to be coming from, will be higher in the sky in the southern hemisphere. So in the southern hemisphere, in the darkest of skies, you should be able to see around about 60 meteors per hour. That's one shooting star every minute. Whereas for those of us further north, the radiant will be closer to the horizon in the southeast, so we're going to lose half of those meteors as they streak below the horizon. So in the northern hemisphere, let's say around about 30 meteors per hour in the darkest of skies, one every 2 minutes or so. But what's fun about spotting a meteor from Eta Aquarids is that all those little lumps of space rock that are burning up in the Earth's atmosphere are left over from the last passage of the famous Halley's Comet. And remember, meteor spotting is just a waiting game. So get comfy. Lie down if you can, because you'll really save your neck. And remember, you don't need a telescope or binoculars to see this. You will just be able to see them with your eyes alone, but they are a little bit of a blink and miss it thing just from how fast they streak across the sky. Now, you will see more meteors the closer to dawn you are on the 6th of May, but if you see a shooting star anywhere from around 2 weeks before that or 2 weeks after that, the likelihood is it's from the Eta Aquarians meteor shower. I'm definitely going to be on the lookout for shooting stars while I'm here in Joshua Tree, obviously enjoying the dark skies at night, but then hikes during the day. Now, if you've ever badly needed an internet connection when you're abroad, either for work or because, like me, you're going hiking and you just want the comfort of knowing that you have signal to check a map, you'll understand what a difference a local SIM card can make. But let's face it, buying a new SIM card in every location and swapping it out with your home SIM card is just so inconvenient. That's why I love the convenience of Saily, the sponsor of this week's video. Saily is a simple eSIM app that helps you stay connected in over 200 places around the world. An eSIM is a digital SIM card, right? It works just the same as a physical SIM card, except you just don't have the faff of swapping out the physical thing. All you have to do with Saily is download the app, choose a data plan, install it on your phone, and then you're all set. You'll have internet wherever you go without any of the dreaded expensive roaming fees, saving you time and money and the panic when you inevitably get home and can't find your home SIM card, because let's face it, those things are so small. And if you're planning on visiting several countries during your next trip, Saily can help you save even more. So if you get a global or a regional plan, say for Europe as a whole, you can then travel just with one eSIM plan and then not worry with every new country you go to. Plus, if you use the code Dr. Becky at checkout, you'll get 15% discount on all Saily data plans. So download the app today before your next trip and thank me and Saily later. So a big thanks to Saily for sponsoring this video, and now let's come back down to Earth and fly home from Joshua Tree and chat about what's been happening in space news in the past month. Alright, the big news this month that we've all been excitedly following was the Artemis II mission. That NASA livestream became my constant companion these past few weeks. So if you've been living under a rock, let me catch you up. After last month's issues with helium flow and hydrogen fuel leaks were ironed out, NASA's Artemis II mission launched from Cape Canaveral in Florida on the 1st of April 2026, with 4 astronauts on board: Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen. Over the next 10 days, they then travelled from Earth to the Moon, a total of 695,081 miles from launch to splashdown, looping around the Moon at a distance of 4,067 miles away from the surface, while at a maximum distance from Earth of 252,756 miles, breaking the record for the furthest that humans have ever been from the Earth.
If I take one more step, it'll be the farthest away from home I've ever been.
The record was previously set back in 1970 by the astronauts on board the Apollo 13 mission, who reached 248,655 miles from Earth, so Artemis II broke the record by over 4,000 miles. After they looped around the Moon, the astronauts made their way back to Earth and splashed down in the Pacific Ocean off the coast of California on the 10th of April. And while we can show their trajectory on a static image like this, that doesn't quite capture how incredible the dynamics of a journey like this are, in the same way that an animated version of their actual trajectory does, which shows both the Moon and the Integrity spacecraft moving. And so you can really see how that gravity slingshot around the Moon has to be so perfectly timed. Just to reiterate, there was no engine burn in that maneuver. It was just complete trust in the Moon's gravity and that people on Earth had got the maths right to actually be able to bring the astronauts back onto a trajectory that would bring them back to Earth. This is known as a free return trajectory, and it's why they only have a handful of days each month to actually launch the Artemis mission because of the relative positions of the Earth and the Moon. Now, this mission was all in preparation for the Artemis IV mission in a few years' time that does actually aim to put astronauts onto the Moon again for the first time since the 70s. So this was like a dress rehearsal for all the new equipment that's been developed for the Artemis missions, similar to the Apollo 8 mission in 1968 ahead of the Apollo 11 mission, the first mission to actually land astronauts on the moon in 1969. Now, we have had some incredible imagery from both the onboard cameras and the astronauts on board taking pictures themselves that have come out of this mission. Everything from the Earth in all of its glory to Earth setting and rising over the moon's surface to incredible detail of craters on the moon and even a solar eclipse. Now, I saw a little bit of confusion online about sort of like the angle that sunlight was coming from in a few of the images. Like, for example, in this image that was taken looking back at the Earth by Commander Reed Wiseman early on in the mission, it actually also contains Venus as the bright dot in the bottom right. And when I first saw this image, I was like, if that's Venus over there, then that's the rough direction of the sun, give or take like a 45-degree angle anyway. So how is it that the Earth looks fully lit as if the sun is behind the spacecraft where they're taking the photo? Well, it helped me when I saw Commander Wiseman's first attempt at taking this photo, which was done with a much lower exposure time, which then made way more sense. You can see what we're actually looking at is the nighttime side of the Earth, which is lit by the reflected light off the full moon behind them. So you can see the aurora in the north and the south poles, and you can see the bright light on the right is from the sunset on the day side of the planet. So the sun is behind the Earth, hence why you can get Earth and Venus in the same photo. And it's why you need that longer exposure to actually reveal the details on the night side of the planet, like the coast of Africa and South America, which you can see here. Similarly, there was a photo that they sent back of the eclipse that they saw where the moon fully blocked the sun. And you can also see Mars and Saturn and Mercury as well. And at first glance, it does appear to be an odd one for where the sunlight is coming from, because by definition, for an eclipse, the sun has to be behind the moon fully blocked out. But again, we can see detail on the left-hand side of the moon here. But that's only visible because of something known as earthshine, where light reflects off the Earth to light up the moon. The same way that during a half or a crescent moon, you can sometimes see the rest of the moon because of earthshine. Now, it's worth stressing here that although these images are incredibly beautiful, they are closer in definition to art than they are to science images. Like, the motivation for the Artemis missions is not science. It has always been political and economical. So we are in another space race again, with the USA wanting to beat China to putting humans on the moon again. And while there is a UN treaty that does stop countries from laying ownership to entire astronomical objects, so not one country can say, you know, I own the entire moon, there is nothing to stop NASA or the Chinese Space Agency or even a commercial company from landing at a given spot on the moon and laying claim to all of the resources there that they could mine and then make money from. These are the reasons that missions like Artemis are getting funded. Those are the deciding factors, not the science that could possibly come from it. Because in terms of science, the Artemis missions are very thin on the ground, right? There's a lot of focus on the toll that space travel takes on the human body. That's all with the view of preparing for longer term missions, like building a moon base or further space exploration, like sending humans to Mars. However, that's not to say that we won't learn something from the Artemis II images. We probably will. We just don't know what it is yet. Could those images have been taken by an uncrewed space probe that would have been a lot cheaper to send to the moon? Yes, although I have seen some field geologists argue online that having a human there to decide, okay, what actually is interesting that I should point the camera at and describe what they're seeing is incredibly useful for their science. But did that justify the cost of this mission at the expense of other astrophysics programs that could have gone ahead instead and taught us a lot more science? No, not in my opinion anyway. Although maybe that just once again highlights the difference between an astrophysicist and a rocket scientist, which are two fields that people tend to confuse. Although I will concede that the Artemis II mission brought many people, myself included, a lot of much needed joy these past few weeks. Correction, shared moon joy.
Kathy Moonjoy.
So it was great to see the excited response on social media, from the friendship bracelet in space to the jar of Nutella to Christina Koch's incredible forearms and to the heartbreaking declaration that the crew wanted to name a crater on the moon after Carol Wiseman, the wife of Commander Wiseman, who sadly passed away in 2020. So I think really there's only one sentiment that sums up the Artemis II mission and all the joy that it brought people these past few weeks, and that is
amaze, amaze, amaze. Thank you, Reed.
Let's stick on amazing views of the solar system for now and chat next about the incredible new images of Saturn, my personal favourite planet. I am obsessed. These have come from the dream team of space telescopes, Hubble and JWST, which together allow us to peer into the different layers of Saturn's atmosphere. So Hubble can detect UV light, visible light, and a little bit into the infrared, which means the light we detect with Hubble is mostly reflected from the top of Saturn's atmosphere. Think of it like the cloud tops on Earth. Invisible light, they block our view of what's below. Whereas JWST detects light in the infrared, which allows us to detect light reflected off clouds much deeper in Saturn's atmosphere. So there's some features that show up in both images, like the ring system. So in the JWST image, the rings are extremely bright because they're made of water ice, which reflects a lot of infrared light. The very thin outermost ring is like really obvious in the JWST image, but only slightly glows in the Hubble image. You can also just see the edges of Saturn's hexagon at its pole in both images. That's a storm that's been raging for decades. I've made a whole video on that before if you want to check it out. It was a very early video on my channel. But it's by comparing these two images that we learn a lot about like the different molecules in Saturn's atmosphere at different altitudes. Like for example, can you see that greyish, greenish colour at Saturn's poles in the JWST image? This is caused by infrared light at a specific wavelength of 4.3 microns, which we think could be due to a layer of aerosols high up in Saturn's atmosphere which scatter light differently. These images were taken as part of a decades-long observing campaign to use Hubble to observe the outer planets and how they change with time, and now JWST is quite literally adding an extra layer to our understanding of how Saturn's atmosphere changes with time. And finally, let's chat about this paper from Libby Roberts and collaborators that used JWST again to study a type of exoplanet known as a superpuff.
Ooh, the puffs, the Chiltern puffs.
They're also known as like cotton candy planets or marshmallow planets because they're so light. So they're about the size of Jupiter, so the same diameter as Jupiter, but they're only 1% of Jupiter's mass. That's unlike anything we've ever seen in the solar system, right? They're so incredibly light and underdense, hence the nickname of Candy Floss Planet, or cotton candy as the Americans say. Now, these things are weird and we don't really understand yet how they form. In the solar system, we think the gas giants of like Jupiter and Saturn formed by first forming a massive rocky core around 10 times heavier than Earth, so they then became heavy enough to rapidly draw in all the gas around them. And because the core is so heavy, they can compress that gas so it is very dense. Whereas a superpuff planet, we think must have started with a less massive core, so one not as heavy, maybe like 2 times heavier than the Earth, and then instead of taking in all the gas very quickly, it took it in very slowly into its atmosphere, and it just didn't have the mass to compress that down and get dense enough, so it remained very puffy. But the problem with having such a puffy atmosphere is that the planet can't hold on to it very easily, and so it should get lost to space. So radiation thrown off by stars hits into the atmospheres of planets and can give the air molecules enough energy so much that they escape the pull of the planet's gravity. A magnetic field around a planet can provide a lot of protection, like in Earth's case, but if the planet isn't massive enough in the first place, it's not going to be able to hold on to its atmosphere. This is what we think happened to Mars over a billion years to transform it to what we see today. And this issue is a particularly big one when it comes to the least dense of all of the superpuff exoplanets known, Kepler-51d, which orbits its sun-like star at less than the distance that Venus does around the sun, meaning it will get bombarded by a lot of radiation from its star, way more so than it would do if it was orbiting much further out at, say, a similar distance to Jupiter does around the sun. And yet somehow it is also the coolest superpuff exoplanet, known at an average temperature of around about 75 Celsius. So as you can probably guess, there's a lot of interest around Kepler-51d and explaining what's going on, which is why Libby Roberts and collaborators applied to use JWST to peer into the planet's atmosphere. So if you wait for the planet to pass in front of its star, you can isolate the tiny bit of starlight that passes through the planet's atmosphere. Then molecules in the atmosphere will absorb unique wavelengths of light, leaving a sort of fingerprint that lets us know that they're there. From how strong that fingerprint is, we can work out how much of that molecule there is and how dense the atmosphere is. It sounds simple, but as always in practice, it never is, right? Because that kind of signal is so weak, and so you end up with very noisy data to analyse. Here's what Libby Roberts and collaborators found for the superpuff Kepler-51d, and as you can probably see, there's really not much there at all in the way of fingerprints left on the light. There's no individual features, there's more of just an overall trend of more light being blocked at longer wavelengths. And what Libby Roberts and collaborators think is the most likely explanation for what is going on here is that Kepler-51d has a really thick layer of haze high up in its atmosphere that is just wiping out any signal from features from molecules lower down in the atmosphere. Similar to the haze on Venus or on Saturn's largest moon, Titan, but on a much bigger scale. Which is really cool to find, and the best fit for this haze has it made up of methane and toluenes, but it's really kind of annoying that our view is blocked. Now, JWST's MIRI instrument, which observes at even longer infrared wavelengths of light, could pierce through the haze, which will help us learn more about what's going on with Kepler-51d, but that entails applying for JWST time again and then waiting for your actual time on the telescope, so that's going to be a few years down the line yet. But the team still do have some JWST data to analyse from another superpuff planet orbiting the same star, which is known as Kepler-51b. And that should tell us if that too has a similar hazy atmosphere or if Kepler-51d is just a bit of a weirdo. I'm going to keep an eye out for that research coming out, and I'll cover it on my channel when it does, so make sure you're subscribed so you don't miss out on that. Alright, that's it for Night Sky News for this month. As always, if you spot any space news stories that you want me to explain in a future Night Sky News video, or if you snap any pictures of the night sky that you would like to share, then tag me over on social media because I would always love to see them. But until next time, everybody, happy stargazing. Opposed to, you know, just a probe taking photos in any direction. Every time I ad-lib, I go wrong. There's a helicopter of some form going over. I will let it go. Wherever you are going, friend. Or are you getting louder? Probably a Chinook. No, I thought that was it. It was a bird.